Good afternoon. My name is Mackenzie Kosit. I'm the global startup evangelist for Amazon Web Services. My background comes from a lot of large enterprises years ago, including Viacom and MTV, doing a lot of logistics works and advanced engineering at DHL. But I got into the startup world back in the Tumblr days. So I was one of the early engineers there, and Tumblr, of course, was the first billion-dollar exit out of New York City. I was a founding engineer at Oscar, which is a health insurance company out of New York City. Today, it's about 1,000 plus employees, valued north of $3.4 billion. And also ran a bunch of engineering teams over at Betterment, which today is the largest independent robo-advisor with, I think, over $15 billion in assets under management. So I have a lot of interesting enterprise experience and startup experience, and it's why I joined here at Amazon to help talk to startups and give mentorship and guidance. So I spend my days actually visiting startups all over the world to hear about what they're building. And it puts me in a very unique position to kind of see trends and patterns that are emerging. It's interesting to see kind of the unique challenges across each industry. And that's kind of what the birth of this talk was. And I think my next slide is the modern startup. Now, when we conceptualized this talk, we thought this would be great. Let's get some of the most interesting patterns and architectures that we're seeing, and let's share this. But in reality, this talk's actually pretty hard to execute. Because as you know, your industry has very niche challenges. And the way you can solve that, there's many different ways that you can architect to solve those problems. But it's not necessarily here's a solution I'm looking at, and let me just copy and paste this into my environment. And that's actually what re:Invent really is. We have all these sessions that are about seeing a 1-hour talk, going into detail about a specific problem and how teams engineered for this. What these talks usually also include is kind of the best practices, what you've learned by doing this or building this. And I was trying to think of how to actually make this talk valuable. And I thought, let's try to go the other way around. Let me talk about some of the most important best practices for actually doing good engineering and architecting systems that I find myself commonly asking startups when I visit or seeing out in the wild. And the hope here is you'll get a chance to kind of go back and figure out the right questions to ask while you're building. So you won't necessarily leave the session with a Terraform of, hey, here's what I can just start deploying into my environment, but questions to be asking your teams, ways to think about whether or not you're on the right path when you're building. These are questions I've run across in every company I've worked at. To hit the technical piece, we also have a guest speaker who is Roy Penn. He's the VP of Engineering of Amenity Analytics at New York City. If you're not familiar with them, Roy built a lot of natural language processing entirely serverlessly. So he's going to talk about kind of the organizational shift and how that evolved from going from a Docker environment to serverless and what that meant for the teams themselves. When I think about great engineering, there's a lot that goes into this. It could essentially be a flywheel. But this is what I think about when I meet engineering teams and they're doing something that's pretty interesting. Right? They're either using best practices that have been proven, they have great philosophical beliefs about how they're approaching problems, they're using proven, tested patterns, they have experience that they're falling back on when they're building. The most important one to me is that they have simplicity. They're building simple, easy to understand systems that are easy to debug. They're open to new technologies, and there's some ingenuity in there. So the 4 areas I want to touch on, and I'm going to back this up with some startup examples to kind of demonstrate why I think these are great examples, are these 4 principles. So to dive in, and these are the companies that I'm going to be using to kind of back up these points. Out of curiosity, is anyone here from any of these companies? No one. Well, let's learn. Every time I'm in any startup environment, this is the #1 thing I spend more time doing. It's just going and trying to find any time that there's a blocker or wait state. Anytime I find any team waiting on another team to, whether it's provisioning a server, whether it's getting approval for deploy, whether it's any kind of human interaction. Anytime there's human-to-human interaction, I spend a lot of my time and my team's time finding ways to automate that. I did a talk 5 years ago at the Atlassian World Conference, back when I was with Oscar, talking about kind of how Chatups change our organization a great deal. And I know Chatups is kind of an old concept by now, but I don't see a lot of teams leveraging it. And I want to demonstrate why this is so powerful within our organization. So the great thing about Chatups is you're able to abstract away from all of these services. So as a developer or anyone in your organization, you have one common, consistent way to interface with all of your systems. So of course, you can do simple things like provisioning a server. Here I am provisioning one and saying this is the branch I want. It'll go, it'll spin up that EC2 instance, but it's also going to make sure it's in the right security groups, that it has the right permissions on it, that it's that's part of the right clusters. This takes care of all of the basically the guardrails for developers. But it gets more interesting. So at Oscar, we dealt with a lot of, it's a healthcare company, so we're in a very regulated environment. We deal with HIPAA. And so our developers are trying to constantly develop against databases that are always changing under their feet. We are doing database migrations often, adding columns here and there, and so in order to develop against that, you need a test database that's actually up to date in terms of schema and data. But you can't necessarily give production data to a developer to look at that. We want to protect our members' data. So again, this is a really nice, simple thing you can do when you start abstracting away from these services. So we had a very easy way for a developer to say, here's my dev database. And when they run that command, it'll pull a snapshot from an RDS instance. It'll run through an anonymization process to scrub that data out. It'll shrink down that data so it's a smaller data set, so we can use a smaller RDS instance, and it'll refresh that dev database. And so this is very on-demand self-service, and it's what we always try to think about when we want to start enabling our development teams. We want to be finding ways to build these tools and services so people can just work on their own, but they have the right guardrails, that they're doing the right thing automatically. But I also encourage you to think beyond just AWS itself. So we're constantly adding and removing VPN users, and so all that's automated to where you can just say, hey, I'd like to add a user to VPN, and it'll generate an email on your certificate. Our goal, this all comes back to finding areas where we found teams waiting on other teams and then building these self-service tools to make it quick to let teams just build and get access to the resources they needed. So the takeaways here are really, anytime you see human-to-human interaction, try to automate that. And I'll show you through a couple more examples where you'll see these best practices emerging. Self-service, there's lots of ways to do that. Just enable your developers and find ways to give them access to these resources. And the biggest piece is, I stole it from the Unix philosophy, but build modularly and write simple parts connected by clean interfaces. This allows you to swap out the components as you start growing. Anytime you build a super tightly coupled system, it makes it difficult to try a new service, to try to swap something in. So if you try to keep these components loosely coupled and easy to swap out when you want to try something new, it allows you to keep trying new technologies and evolving that infrastructure. This ties into, of course, enabling your developers. One company I've been working with for years out of New York City is ZocDoc. They had a very interesting problem, which was they were primarily a Windows shop at the time. They wanted to migrate a lot of their infrastructure over to AWS. They wanted to start migrating that to a lot of open source projects and Linux. But their team of 100+ developers had very little experience with using AWS. And so the CTO at the time, Serkan, he's done great talks about this. His solution was, I'm just going to give every single dev in my company a $100 account to play with every month. And those accounts are going to get deleted and recreated, so no one's going to build anything that will become production all of a sudden. So this allows developers kind of to get their hands on new services and play around with them. Well, this is enabling them by giving them access to the 200+ services we have today, but it's not really giving them a goal of something to build and solve within ZocDoc's environment. So hackathons became a really big part of ZocDoc's culture, which is really a critical piece. They would have a little Shark Tank-like show within the company, and people would pitch their ideas of anywhere they saw a pain point within the company. They would pitch, hey, let's try to build this. Here are some Amazon services we can use to try to solve it. And a lot of interesting innovation happened within ZocDoc once they did that. So they've migrated over entirely in terms of basically enabling these 100+ developers to be familiar with AWS. And there was a great talk last year about stuff they're doing around machine learning and being able to read insurance cards. So a lot of this stuff comes from again, being open to having your company, play around and actually experiment. It's more fun. So again, when I see good engineering within companies, it's companies who are enabling their teams, they're encouraging and testing these new ideas, and they're open for suggestions from across the company. Next thing is everything continuous all the time. This again goes back to wait states, people kind of sitting around waiting for things to happen. Nextdoor, like many companies, still has a pretty big monolith. I mean, Slack, Instagram, other companies still have a monolith that's hard to get rid of over time. It takes time to do that. But they wanted to figure out how to kind of speed up their deployments. So the first approach is kind of tackling doing continuous deployment with monoliths. And their approach to doing this, and there's a great engineering blog post you can read about this, titled, well, it's up there at the top. But their approach for this was just doing release trains. And if you have to do monoliths, this is a great approach. But as they started to deploy microservices within ECS, let me back up. When they were originally deploying these services, they were using Debian packaging. They're basically doing the Redblack deployment that Netflix recommends for deploying whole new infrastructure, deploying out these Debian packages and running them. And it was taking about an hour to do a full deploy for them, which is actually terrifying, right? You get your code out to production, something goes wrong, and that means you have 1 hour to actually roll that change back. So again, there's a lot of great talks from Nextdoor about their migration and how they did this deployment, or did this migration. They have a great blog post about it. But they ended up landing on doing ECS and got the deployments down to about 5 or 7 minutes. So today they're doing about 20 or 30 deploys a day. And what was the quote I put on here? Oh, why this is important. Every single company I've ever worked at, it always starts with how long are deploys taking and why is that? And that ends up being a 4-month investigation process and trial and error and digging into it. And so my biggest takeaway from this is find those things that are taking a long amount of time and encourage your company to be asking those questions and trying to solve it. Nobody wants to sit around waiting an hour for deploys to happen, and it always starts with a simple question of why? Why are we waiting around for an hour on this? And again, you'll see the self-service piece down below that Nextdoor's whole goal across engineering is helping enable the developers. So takeaways, again, how long does X take? Keep diving into that. And a lot of people try to figure out, well, what's worth spending time on? And my favorite question that you can always ask an engineering team is, what problem are you trying to actually solve? And that will prevent a lot of, there's a lot of people who want to just build something because it's a fun thing to work on. But when you get down to the core of, are you actually solving a problem for the business? That helps kind of dive down to whether, or basically drill down to whether or not it's a valuable time or valuable place to be spending engineering resources. And secondly, if you can't actually demonstrate that there's any kind of bottleneck that exists, then don't spend time to improve it. There's plenty of times I've seen teams who are just swapping out languages or technology just because it's something new to play with. But that last point really kind of eliminates those time wasters. It's funny how often when I talk to teams and they say, oh, we have this really amazing stack, and they talk about how complicated it is. And in a way, when I'm hearing this, it actually just pushes me away from thinking that they're actually doing great engineering. To me, great engineering is about building simple, understandable systems. At Tumblr, we had a thing that we called the 3 a.m. test. It meant if you wake up and you're drunk at 3 a.m., can you make sense of these systems? Can you figure out what is going on? And if you can't, then your systems are too complicated. If you're not familiar with John Gall, he had a law. The law states that all complex systems that work evolve from simpler systems that worked. If you want to build a complex system that works, build a simpler system first, and then improve it over time. If you try to build a super complicated system and then hit the power on switch, it is very likely to fail. And that's Gall's law, essentially, is that you want to be starting with something simple and evolving it over time. And when you do that, you keep the other principles in place, making sure it's modular, making sure it's understandable. And so let me give you an example of how this can play out with great engineering. Reddit had an interesting challenge. They wanted to start serving out 1 billion video views natively on their platform. And that's 1 billion views a month. A lot of companies look at that and say, that's an enormously big task and challenge. Let's get a team on it. Well, Reddit put 2 people, I think roughly part-time, to solve this for them. And in a very short amount of time, they looked at what they had to build, and they built a very simple architecture, which essentially just puts, it receives the video, puts it into an S3 bucket, it processes it with Lambda to do the transcoding on it, and then it uses SNS and SQS to publish back that transcoding was done. Now, to me, this is great in engineering because they're processing 1 billion videos a month. They had a very small team to do this. And everyone in this room can look at this slide and very easily, if something's not working, it's very easy to look at this diagram and figure out where something's probably not functioning correctly. So again, you can do a lot with simplicity. I'm about to share a time when something went horribly wrong, which these are always the best stories, and people, I think, get a lot of thrill out of hearing when companies or entire sites go down. And I want to tell this story because a lot of people want to be engineering safety features into their infrastructure. They think, I want to add more automation and more control to where bad things can't happen. And every time you do that, you're just introducing a more complex and complicated way that your systems can fail magnificently. And to demonstrate that, or to give you an example of that, at Tumblr years ago, we were sadly running in a data center. We had 3,500 servers sitting there. We were using Facebook's Scribe service to aggregate. We were generating 3 or 4 petabytes of log data a day, and it was going to these central log servers. We knew that forwarding these logs off our web servers was critical, and so one of the features we had in there is if a log server stops forwarding log messages, it'll generate an error saying, hey, I'm not able to forward these logs, which makes sense. Where this failed us is one afternoon, one of the engineers upgraded the servers where these logs are being aggregated, didn't realize that it wasn't receiving any more log data. So all of a sudden, there's 3,500 servers who are trying to contact and say, hey, I got log data I'm trying to send you. We have millions of people trying to hit this website. And what do these web servers do? For every log entry that it couldn't forward, it said, hey, I can't forward this, which generated another one that said, hey, I can't forward this. So it started multiplying very quickly. And so the safety feature ended up being pretty damaging to the infrastructure to where suddenly you saw web server after web server go offline, database servers going offline, caching servers go offline. Every single server within the infrastructure died. And it caused about a 12-hour recovery going to this physical data center and powering it back on and restarting everything in the right order to make sure a caching layer didn't slaughter your web servers. And so I tell this because the intention was right, that we built the safety mechanism to tell us when something wasn't going correctly, but it just amplified the problem to where it completely obliterated our entire site. So whenever you're adding a safety feature, just be aware that it's added complexity that might actually end up hurting down the line. And if you talk to people who there's a lot of great talks around chaos engineering, which is fantastic, but that balance of how much safety versus, where is that line of how much safety be building into your infrastructure? And that's kind of an ongoing debate. So it's interesting. I think chaos engineering is fantastic. I highly encourage it, but just be aware. I was reading the 3 Mile Islands post-mortem, and I came across this, which talks about, generally a lot of the time, these big system failures are something human, something tiny, and it just ends up manifesting itself in a much larger way. So it's a great law there. Here's some takeaways. Democratize your data. I'm going to skip through this very quickly, but another great example of a company that's doing good engineering in which all these principles expose themselves is with Intercom. So Intercom had this problem where they need to make sure that when they're contacting a user, they're in the proper state. And user states evolve and mutate over time. And if the message doesn't get sent, they need to start debugging it. So the customer service team would then contact the engineering team and say, look, we're trying to find out why this message did or did not send for this user at this time. And they would go grepping through logs. It would be error prone. It would take a lot of time. And so here you have this human-to-human interaction. You have a team that's dependent on another team. And the two engineers there decided, you know what, let's build a self-service tool to do this, right? Which goes back to that first point. So they looked at it and they said, you know what, we'll use Dynamo streams and we will capture the different states of users and we are going to store that into a user history DynamoDB table. And we'll build a simple Ruby interface to this. And now the customer service team was enabled to go and research anyone they need, which essentially within seconds, they can answer this question on their own. So here again is very simple infrastructure. If I look at this, it's solving a really good problem within the company. If something breaks, I can very quickly look at this and figure out where a component's breaking. It just has all the principles we've been talking about so far. Not a lot of added extra safety features. It's not logging whenever it's saying it can't log. But this is again, just a good example of how these engineering practices come into play when I come across good architectures. The last piece is really developing a culture of openness. I grabbed these stories from talks that these companies have done, from engineering blog posts that are posted. There was nothing more valuable. That's a terribly worded sentence. One of the most valuable things that I encouraged with any of my engineering teams was getting them together with other engineering teams within the city and just sharing what they're building. To brainstorm and iterate with other engineers and say, look, I'm thinking about building this and testing this out. Do you see any faults with this, or do you have a different way to do this? It's so much quicker than actually trying to deploy this yourself and test it and build it. So we're able to through just talking, iterate on these architectures, infrastructures much quicker. A company who does this really well, if somebody asks who's an example of somebody who we should be replicating, is Segment. For example, their entire ECS infrastructure and all their Terraform is on GitHub. It's a public repo, so you can go on there and you can deploy the same enterprise-grade ECS environment that Segment has. And they have tons of contributors on there. They have people working on issues and pull requests. But here's a company who's being very open about how they're building and architecting their systems, and they're getting the whole community to help improve their own stack, which I absolutely love. So it's a cool project to take a look at. I don't think anyone here disagrees that open sourcing projects or what you're doing is valuable, but it just takes that initial push to get your company to start doing it. The second thing is just writing these blogs. This is a great blog that Calvin, their CTO and co-founder, wrote about a month ago. And he talks about a $10 million engineering problem, which is looking at the total cost of goods sold and figuring out how he can tweak and optimize his infrastructure to squeeze an extra $10 million of revenue out of his business. And he talks about what they looked at, how they drilled down to find out where the best amount of time should be spent to optimize the return. So Segment's just a great example of that. My final conclusion on this is you can build complex systems, but each component should aim to be simple, modular, leveraging available APIs, stuff that's off the shelf. Don't build stuff that already exists. Here's a good piece of this is if you're thinking about trying to build a gap within one of the services that exists today, talk to your account rep and say, look, we're thinking about trying to build this solution. We're going to have it done in about 3 months. And they will be very open with our roadmaps to find out if this is something that we're going to be providing down the road. A lot of times I see teams spend a lot of resources and time building something that ends up being an offering down the line. And so I just be aware of where you're spending it, what problems you're actually solving. And then once you actually do that, go out there and build and share it. But I'd actually like to take the chance to welcome Roy up. So please, round of applause for Roy. And he's going to talk about the impacts in philosophy and culture when shifting to serverless. So.
Thank you, Mackenzie, for a very inspirational set of examples. I hope that I can show how some of those examples reflect inside Amenity's journey as we worked our way from serverful to serverless infrastructure. And by the way, if anyone has any questions, raise your hand if we have a couple of minutes. I'll be happy to answer those. A nice thing that I have in my mind all the time is that technology specifically doesn't disrupt anything by itself. You can say, Lambda functions, they disrupt everything, or any other piece of technology. What they actually do is they bump up people's expectations. And when people have higher expectations, then that's where ideas start flowing, and then that's where they disrupt the industry. And in Amenity, what we do is we provide any of our customers, anyone, for example, for that case, if you approach us, the ability to leverage NLP tools, natural language processing tools, as if they were experts in NLP without having to actually go through all the headache of learning it and building it themselves, et cetera. A good story about that is that companies, when we told them, customers, future potential customers, we told them, hey, we're so great at NLP, hire us, they didn't care, right? Because they didn't care about the tech. What they cared about is what they can do with it, and if they had higher expectations, now they could imagine what problems it could solve for them. Generally speaking, if you look at an NLP, natural language processing, or any machine learning, for that matter, process, you'd see that it could take several months to build locally, just homegrow a team, and then have some specialization. A lot of money has to be involved. With Amenity, what we do is we squeeze it down. We have all the tools to squeeze it down to several weeks, and very little money up front. Just a little bit about us. We're a little over 60 employees. We're half in New York, half in Israel, raised a little over $25 million, and we're backed by Intel, State of Mind, Star, and Allstate in the insurance industry. And these are some of our customers. And a nice thing to see here is that these are not any low-hanging fruits. Like you go to Nasdaq, they have really high expectations. They want things to work all the time. And so if you go and say, oh, I'll move from serverful infrastructure that everybody has to serverless, and they don't go lightly about it. They don't go say, oh yeah, sure, go with the bleeding edge. We'll back you up with it. This is how our architecture, Amenity's architecture, looked like about 1.5 years ago when I joined the company. Every circle you see there is a Docker-based microservice. It's hosted on ECS, and they're all trying to speak with each other, trying to figure out what's going on. And then about 1.5 years ago, our CEO contacted me and he said he wanted me to join. And here's a nice challenge for you. He said, I'm going to take care of bringing 100x more customers. You just need to take care of making things 100x faster. And by the way, I want to serve them 100x more data. And you've got to make it cheaper. And I said, sure, why not? Let's give it a go. We thought about our principles, what it means as an engineering team to be able to serve and to adhere to such a fit. And one of the key things that we wanted to preserve is our agility as developers, as teams, and as a company, right? If Moody's or Bank of America, they come to us and say, I need something quickly, we just can go and say, okay, well, our next iteration is 2 months down the road. We've got to deliver quickly. We need simple deployments. So in order to enable and empower our developers to try out new ideas. And we need flexible scaling because a company might say, process these 100 million documents, see what you find there. And so we have to scale up extremely fast and then scale down. This is a little shift that we did in Amenity. We went from Docker to serverless, TDD all the way, lower level understanding of our infrastructure. That means that our expectations from our developers increased dramatically. Every developer, we canceled DevOps as a different entity, and we merged DevOps and QA. Every developer is a DevOps. That works for startups our size, maybe up to 200 people, maybe. Probably wouldn't work for Amazon or Google. But the point here is that we wanted to make it so that every developer understand the underlying infrastructure. Just imagine the amount of strength every developer has if they understand OS, right? What's going on in the scheduler? You know, how to access threads. And then they have higher amount of power if they know how the CPU works, you know, different L1, L2, L3 cache. If you squeeze all that information into people, you expect them to know about it, then you get better results. And so this is how our architecture changed. Java, Docker, EC2 to Python serverless on Lambda. And one of the key things here is that serverless allowed very confined understanding and to make an impact quicker on every developer. The developer didn't have to understand all the networking and everything. They could just look at one operation, one Lambda function, one microservice, and then understand it dramatically better than anything else they did. They could fiddle and they could play and say, I want more memory. I want more time for it to run. I want this Lambda function to speak with other services, and they're confined, and so they can drill really, really, really deep. This is how our infrastructure looks like today. First of all, there's something nice to note here. There's an infrastructural pattern that we're probably going to change now that Amazon released Lambda async. But every microservice speaks queue, Lambda with some database, and then notification. Everything from left to right. Every green block that you see there is a microservice. Far fewer microservices than what you used to have. On the left-hand side, all the data coming in. We have about 1 million messages. Messages meaning articles, news articles, earning call transcript, SEC filings, documents that could be as long as 2 paragraphs or as short as 2 paragraphs or as long as 100 pages. And they all have to go through the system and be cleaned and properly analyzed and then exposed on the other side as API or SaaS service or dashboard. One of the ways that serverless jives with the culture that McKinsey talked about and the one we wanted in Amenity is that it empowers, increases independence of the individual and of the teams. Smaller services means that people can completely understand what they work on and then glean insights on those just services. It increases the local simplicity. So if I want to make a change and deploy it, it's really easy. It's just this one Lambda function or 2 or 3, but very, very confined. I need to change that. I can change it very easily. I have the tools to deploy it to maybe 5% of the users, maybe then 10, 20, et cetera. And then if I have a problem, I can roll it back. Micro-optimizations become very easy to measure and then deploy. So you can speak with a developer or a team and tell them, you know, here's this microservice, make it more scalable or make it cheaper or run faster or whatever it is you want. They're very easy to distinguish between with other microservices. As leaders, it allows to increase expectations on both a local and global basis on every developer, so that I could articulate my expectations and tell people, okay, now I expect this microservice to really become optimized or to run faster or to become cheaper. This is a good example of how much thing cost us when we moved from long-running servers, auto-scaling Docker to serverless. This is a normalized cost. Generally speaking, this is about the cost of 1 million documents that we process in dollars. And so you can see that even running Docker containers or Kubernetes and having them scale up and scale down really, really quickly doesn't have the same effect of having Lambda functions or serverless really scale up really efficiently and neatly into exactly what it is that you want it to do. Another example is how much time things take us, right? You can see here the percentile of how many seconds it takes us to process between all our articles, news articles, and et cetera, between when they arrive, become available on the internet, and until we make them available on our API. And so 25% of all the documents that we process every day, so about 250,000, become available within 40 seconds of when they are released to the public. This is about 4x or 9x times faster than if done on a Docker container. The drag here is now, as managers, you always have to ask yourself when to, instead of asking when to split a microservice into a service into two, a microservice into two, you have to ask yourself when to join. Otherwise, you'll end up with a myriad of Lambda functions, and they're all trying to do different things. And different people in different teams would write essentially the same Lambda functions because they didn't know that other people wrote the same thing already. And so that's the drag. It means that you require a very strong architecture in place and very good communication between team leads, team architects. And one of the things that I like, people ask me why we did NLP over serverless. We are the only company that I know that do NLP over serverless. By the way, if anyone here does NLP over serverless, I would like to recruit you. And so raise your hand, and I will do that. But it's a problem because NLP is such a resource-intensive operation. And so it just jives well with just give it as GPU and let it run. But then it costs a lot of money. I think serverless for us as an architecture and what affect our culture allowed us to try and do things that are almost impossible. So first of all, people ask me why almost, and that's not to get too nitpicky. If it's impossible, then you can't do it. But how do you know that it's almost impossible? Unfortunately for me, there is no easy way to know it's almost impossible. Most people would tell you it's impossible to do NLP over serverless, but you can you do the calculation and then you go, okay, I think I can do that. But it's really hard to recruit for that. This is how our NLP stack looks like. This is roughly how most NLP stacks look like. It's a 12-process step. There are 3 other steps that you can see here. Generally speaking, if you ever want to do natural language processing, the first, I want to say, 6, you're definitely going to go through. What we do in Amenity is we have to retrain every one of those for the Financial Institute language, but we also had to rewrite each one of those so they will fit a Lambda function. Generally speaking, if you just take off-the-shelf NLP tools, all those processes will run on the same computer, just one after another. So by doing that, by splitting into the 12 layers, serverless helped us with our incremental delivery. The 12 layers now become, each layer is its own different Lambda bundle or function, and we can change each and every one of them as we would like. And it helps with free developers from their past perception that everything has got to be monolithic and this is how you do NLP, and they could move forward. This is how our older architecture looked like and how our new one looks like. Clear NLP, Java, Docker, EC2, most NLP works that way. We moved to Spacey, Python, but Python wasn't compressed enough, so we had to do Python and C, and then we could deploy it in AWS Lambda. A lot of the tiny pieces of NLP, nair tagging, whatever it is, entity recognition, we had to rewrite in such a way that was small enough to fit inside one Lambda function. With the main, McKinsey suggested we always ask our developers, why do you do the thing that you do? The main thing that we want to accomplish here is we want to shorten the creativity cycle, right? If you build a good architecture, if you build a good culture, the time it takes between someone having an idea until they try it out, not have necessarily in production, but preferably in production, try it out and see if it works or doesn't work, the shorter it is, the better the state of the company is. You could go as deep or as wide as you want, algorithms or architecture. This is the state where we got to, where NLP was roughly 100x faster. You can see loading a model, an NLP model normally takes a few tens of seconds. Now it takes a few tens or hundreds of milliseconds. The memory footprint went dramatically down from 1 gigabyte, which could never run a Lambda function, to 50 megabytes, we can easily fit in a Lambda function. Our next goal is about 1 billion documents in less than an hour. Decision-making gone serverless. This is one of the things that I try to speak about with my team all the time. Most of our decisions, most of the day, are done by exhaustion. This is how decisions usually happen. Someone talks with someone, they go, oh, I can't figure out which option is better. I'm just going to go with you because I want to go to lunch or whatever, right? Or we sat in a room for an hour and a half, and then someone said, okay, you know, I just stop talking. I'm just going to do what you say. And it takes too long to get through all the data. Sometimes the decision between two options are too close. It's like when you stand on the ground floor between two skyscrapers. One of them is 60 stories high, and the other one is 62 stories tall. And you go, which one is taller? And you can't tell because you're at the ground floor. And the way to get more information is, you go to another skyscraper, a third one, and then you look and you take your protractor, and you try to figure out the angle, and then you'll get more information. Or you can just get into one of them and try, right? You just go zip to the 60th floor and see which building is taller. And you can do that easily with serverless because you can deploy the tiniest change really, really quickly and then figure out if you broke anything, and if you did, you undo it. And that's really important. The last thing I want to say about serverless is that even though I like it a lot, it's not for everything, obviously. And people get emotional about it. The problem with emotional decision making is that it's often irreversible. And so if you think about serverless, first of all, I'll be happy to help and talk about it later, but there are easy ways to figure out if it's worth it or not worth it. The basic one is to try a different thing and see if it still hits your goal, right? I read an article, a post, someone said, oh, serverless increased my cost by 10x. All they did was serve a static website. Obviously, it will impact their cost negatively. But if you do other things, it could really, really help. This is an example here of how our product actually looks like. You can see how you can easily figure out. What you see here is a bunch of financial numbers about how much people talk about ESG, how many emissions they have and how many accidents they had. And everything here is powered by our serverless infrastructure. And we're available on the marketplace, which is really hot for us because it's only a few days old. Thank you very much. Does anyone have any questions? I'll be happy to answer. Yes?
How important is it for you to have an environment for your developers to test their code with this in the cloud? Do you try to do that? Do you try to run things locally, or do you have to actually push everything?
Yeah, so the question was, if we test things locally, how important it is to test locally, in which environment, and so we still try that out, by the way. We try a lot of things out. Initially, we had our local, then dev stage environment, dev stage and prod environment. Right now, the way we go about it is, first of all, obviously we have to test. We write tests in the lower levels, but also we test in production. We test in production a lot, and that's where we're going. And so by writing tests during development at TDD, you can root out a lot of the basic problems. but you've got to test in some environment, and we chose to test in production. Any other? Yes?
My question is an extension to the previous question. So when you were migrating from the container services to the serverless, how did you create how did the developers started working on testing their solutions before they actually go to the actual production environments?
So, okay, so the question is, when we were migrating from container-based serverful to serverless, how did we test each and every one of the services? So the way we did it is, first of all, we took a bunch of developers and we trained them. Initially, we put them aside. We said, okay, this is a great fit for the company. Initially, we need information. We need to know. We need to know that serverless is the right thing for us with all the infrastructure for it. And so we spent a few months training people and building this basic architecture from beginning to end. And then, once you have the basic architecture from beginning to end, with everything, with logging, with testing, with everything, full deployment, then you can take and replace. You can start replacing things. But just remember that there's a lot of training and questions that are going to be asked. Yes?
How is your traffic looking like? How many pages are you producing?
How many what?
Like pages of content you're producing per minute?
How many pages are we processing per minute? The way it looks like is like this. Every day there are a million new documents that come in. Every day, a million new documents. So that's roughly about 1,000 or so every minute. But that's just the ongoing. When a new NLP use case is being presented, say, a company comes and say, I want to find out all the times that other companies talked about risk in their portfolio. And so now you have to go back like 10 years, and you have to figure out, you have to process all those documents. And so you have maybe 2 hours, 3 hours to process 10 million documents. A lot of spinning up and down is going to take place at that moment. Yes? No. Okay, so the question is if we had to stop and then rewrite everything. We couldn't stop because 100x more clients meant that they were still coming. So we never stopped. We took a hybrid approach. Number one, a new feature we built from scratch on serverless. But another thing that we did is we started replacing with the existing architecture, we started replacing it piece by piece. You can never stop. I mean, I tried to ask my CEO, I told him, can you stop selling for a year and a half? He said, no. Didn't work. Yes?
You said serverless is not for everything?
It's not for everything. Serverless isn't.
What are some of the things that you tried serverless on and found out it's not right?
Okay, so why do I say that serverless isn't for everything, and did I try anything that it didn't work on? For us, it worked for everything because we did a calculation to begin with. It's not for everything because Amazon has almost 200 services. It's not going to do everything for you, right? It's very specific. Look, a computer can be in one of 4 states at any given moment, or one or at least one state in any given moment in time. It can be idle, it can be bound by CPU, by RAM, or by I/O. If you are in a place where most of the time your resources are underutilized primarily by CPU, then you should probably try and go to serverless. Yes? What was the experience with debugging? Debugging our serverless code? Yeah, the problem with cutting edge is that there aren't a lot of good tools out there to write. But serverless code is still Python mostly in YAML, right? And you debug on production a lot. That's for sure. We also wrote our own tools a little bit, but you write a tool and then 2 months later someone else writes a tool and it's better, you want to replace. Yeah.
Shift in language seems like it would be a big change for the team. Python.
Yeah.
A lot of that borne out by just start time and what you found in the Lambda environment is like.
Okay, so the shift, we did several shifts, but the question is, how did we work, or how do we combine the shift in architecture, the shift in language, also shifted into TDD, so a mindset shift. Yeah. So when I started the company, it was Java 8, but Java 8 was being declared as the end of life. We could have chosen to go to Java 11 and now Java 12, but we didn't. Java is a very still. It's a heavy language, heavy in a lot of places, and so you can see that for example, a Lambda function could take 250 megabytes in Python, but only 50 in Java. Right? It doesn't leave a lot of room. We had to make a change. It's true. Some of our change is to retrain developers, Java developers to Python. The ROI on that is amazing. They are fast as lightning 3 months in. That's amazing. Yes? I can elaborate maybe later about how we test in production, but not right now. There are a lot of tools involved for that. Debugging in production, testing in production, it's great. You're going to love it. Any other questions? Yeah.
One of the advantages of serverless is, like you mentioned, if you have a lot of idle time,
Yeah.
your pipeline, that makes sense. It looks like you guys have dropped this down in continuous. Was there any cost saving on that?
Yeah, for sure. I can show you. This is how it looked like. I had the graph right here. So the question is, if we have, ultimately we have, are we on? Yeah. Ultimately, if we have 1 million documents every day, then why do we need to spin up things and spin them down and spin up and spin them down and then instead of just holding a few servers to do everything? So first of all, the numbers, $3.8 for every $1 on auto-scaling Docker, even Kubernetes versus serverless for us, right? And the reason is that 1 million documents every day, and say 100,000 seconds, you get about 10 documents every second. If you can make it so that processing, and process has, let's say that processing has 5 or 6 steps. If you can make it so that your processing steps would take less than 1 millisecond every step, then you're good to go. It'll work for you. But if every step is bound differently, one step is bound CPU, one step is bound I/O, one step is bound RAM, then you're going to waste resources along the way. If you just have one computer waiting, writing to S3, it's still waiting, right? And so you can really optimize a lot. For us, we were able to optimize it 4x, even in that use case. Any additional questions? Yes? Long cold, okay. Serverless application will have long cold start time. That is only true. First of all, it's okay. It's something like it's a notion that was kept from maybe a year or two ago. You can keep all your serverless application warm all the time at almost no cost, and then their warm-up time or spin-up time would be about 50 milliseconds, and it'll be almost no cost. There are tools to do that for you. Just keep everything warm at almost zero cost. Great. Any additional questions? Perfect. Thank you very much, everyone. It was great.